TK, everybody. TK, 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 TK to YouTube. Okay. Awesome. Okay, guys. So, what do we got? What do we got for our last or our second to last lab for class? What are we talking about here? So, urinalysis. All right. And remember, guys, this lab was really quick. From your, it took 45 minutes to an hour to do. There's really not a whole lot for me to like really discuss here. Experiment 1 and experiment 3 is pretty erroneous in terms of like talking about content. Experiment 2 is a little more hefty. So the majority of the things that we'll actually be doing tonight is 1, pre-lab prep, talking about experiment 2, and then also talking about renal clearance. Okay. So I'm trying to think about how I want to split this video up. I think what we can do is do pre-lab prep, do just a quick little rundown of what we did for experiment 1, what you guys should have gotten here, and then we'll move on to experiment 2, and then we could do 3 very quickly, and then we could do renal clearance. So I think it'll be like 2 videos basically. Okay. So with that, guys, let's get going. So 6 learning objectives. Okay. And first of all, the first one is done in this section of the pre-lab prep right here. Okay. So we'll get that done right away. Some of the other ones here: identify abnormal urinalysis results and define key terms related to abnormal components of urine. That'll be done in this section right here primarily. Okay. So with that, without further ado, let's get rolling. Okay. So we're talking about general properties of urine for a healthy adult. What kind of things should we be seeing? What numbers should we be seeing? Okay. So specific gravity. Okay. And this is a number. Okay, that ranges roughly from 1.001 to 1.028. Okay. So the lower the number, okay, basically means that your urine has less weight to it, essentially. Okay. So if you have less weight, it basically means that you're super hydrated, because your urine is deciding that it wants to excrete more water molecules, versus if you're on the higher end, like up here, okay, it means that you primarily have more waste products in your urine, aka you're more dehydrated, so your body is holding back as much water as possible to keep those hydration levels as optimal as possible. So we're excreting more waste products, other stuff in our body, okay? And then we have the osmolarity, guys, okay? So this number roughly runs from about 50 to it's about 1,200 milliosmolar per liter, okay? And remember, the calculation to get this, you just take the last 2 numbers, which are right here. So like 0, 1, so 1 or 28, multiply those by 40, and that would get you roughly your osmolarity values, okay? We'll talk about that calculation in experiment 1 very briefly. Your pH level roughly will run about 6.0, okay? So it's a little on the acidic side of things, all right? Excuse me. And then the volume, so how much urine are you producing and how much are you excreting per day? On average, it is going to be about 1 to 2 liters of urine, okay? So that's it. So these values right here. So if we were to ask you, for example, on your guys' celebration, what is excuse me, what is a normal value for specific gravity? We would want you to give us a number inside this ballpark right here. And then same thing for osmolarity. What's a normal number? It'd be somewhere in this ballpark right here. Okay? So those are those ones. That's learning objective number 1. Pretty straightforward. Okay? All right. Table 10.2. So this is going on some more terms here. And guys, these terms, like, trust me when I say this, they are pretty straightforward when you look at them. So all that you're trying to define here is, what specific thing is in the urine. Okay? So aka glycosuriya or glucoseuria. What is in the urine? Well, guys, it sounds pretty similar to like glucose or glycogen. So basically what it means is that you're having glucose in the urine. Okay? And you guys are going to see this general trend with all the terms that we have here, okay? So ketonuria, okay? What's going to be in the blood? Ketones, okay? Having ketones in the blood, a breakdown product of fats. Okay. Hematuria, okay? So this is relating back to red blood cells, aka having blood in the urine, okay? Having blood in the urine, all right? Proteinuria. I think that one's as straightforward as it gets, right? What's going to be in your urine? Well, having protein in the urine, okay? Like I said, guys, pretty straightforward terms. Pyuria is a little bit different because it's not as straightforward as the first few, but pi is referring to, in terms of pi, it's referring to py. It's talking about having like pus or leukocytes in the urine, okay? Having pus or leukocytes in the urine. All right. All right, so this is one is talking more about the quantity of urine that you're excreting so that you're actually peeing out. So diuresis or polyuria is the process of having a very high urine output, okay? So urine output roughly above 2 liters per day, okay? So very, very high. You're peeing out a lot, okay? Oligouria, all right? This is having a urine output of less than, let's see, there we go, less than 500 milliliters per day, all right? Then anuria, so an means without, so basically you're just having like no urine being peed out. So this is about peed out. So this is about having an output of 0 to 100 milliliters per day, all right? Okay, so those terms right there. And then we have some little questions down here, guys, okay? So this is related to renal clearance, which we'll talk about in the second video. But the calculation or the formula that we are going to use for this, okay, is C, which as it says here, that's the renal clearance value. So you're going to use C is equal to, and then we have some other variables here. So U, V, and P, where U, V, and P are going to be the following, okay? So U is going to be, guys, this is going to be your concentration in urine. And this is related to a specific product of whatever. This could be like blood in the urine, so how much actual concentration of blood is in the urine, okay? And then V could be is the rate of urine output, all right? And then P is the concentration in plasma, all right? So how much of this is found in the plasma, which is it's a part of your blood essentially, okay? So for example, we could have like a molecule or let's say we have a whole bunch of sodium. So how much sodium do we have in the urine? How much sodium do we have in the plasma? What's the rate of our urine output? And that's going to give us our renal clearance. And the formula for this, guys, is going to be your concentration in the urine, U, multiplied by your V, the rate of urine output, divided by the concentration in the plasma. All right. We'll talk more about this when it comes to which one is it more secreting or is it more of reabsorption. We'll talk about that when we get to the second video. Normal GFR, so what's the normal glomerular filtration rate? So how quickly, remember this is related back to that juxtaglomerular apparatus. What is the general rate for a young adult male for how quickly we're filtering blood going into that glomerular capsule, that Bowman's capsule? This is about 125 milliliters per minute for a young adult male. All right. So perfect. So all these things right here, guys, relate up to learning objectives. So learning objective 1 right here. Learning objective number 2 is going to be this one down here. So we got those ones out of the way. Okay. All right. Experiment 1. So remember, guys, we gave you these vials of urine, and they were labeled low, normal, and high, respectively, okay? And all that we wanted you to do for these guys was to, 1, observe the color, observe the pH values, the glucose, the protein, and then the specific gravity and calculating the osmolarity from it, okay? So we had you, drop all those drips on those individual squares in total, right? So we had you do that. What results should you guys have seen after you dropped things on there, okay? So roughly the color, so if you remember back, the color of the low should have been like a light yellow, so let's write that in there. So it should have been like a light yellow color. The normal was a yellow to a yellow-orange color or something like that. And then the high one was more of like that amber color, that dark amber brown color, all right? pH values, what should we have seen? For the low side, it should have been less than 6, so it was a little more on the acidic side, all right? For the normal, it was running about 6 to 8, so it was kind of dipping its toes in between the basic and the acidic side, roughly sitting neutral. And then the high was greater than 8, so it was much more on the basic side, okay? And then glucose in the low, it should have been negative. It also should have been negative for protein. And then your specific gravity, all right, I gave you, I forget the value I had, but it roughly was around like 1.010. So you have this, and if you put that into the milliosmolar, it is roughly below 400 milliosmolar per liter, right? And then for the normal, what was the glucose? Well, that was also negative and negative once again. And then this value was, gosh, there was such a big range for this one, I think. So 1.010, and it should have ran you to about 1.0026. Gosh, I got all my decimals all messed up over here. There we go. No, thank you. And then this value calculated multiplied by 40. It's about 400, about 1040 milliosmolar per liter. We'll shrink this guy up here. And then for the dark amber one, so this one should have been positive for both the glucose and the proteins in there. And then our values here was something greater than 1.026, and we multiply that number by 40. That's going to give you about 1040 milliosmolar per liter. All right. Okay, so this one was just a screen, all right? It just wanted you just to get a little comfortable with how the urinalysis actually works. We didn't ask you to do any differential diagnoses here. It was literally just getting hands-on with the stuff and then just testing it, seeing what would produce a positive or negative result, how to calculate specific gravity, which, by the way, that calculation, guys, is right here, okay? Remember to take the last two numbers, multiply by 40, you get your milliosmolar per liter. Guarantee we'll probably see a question like this in the next couple weeks, all right? Okay, so I'm going to stop the video here, do experiment 2 next, and remember this is the one that's kind of dipping its toes into the diagnosing the patients and stuff like that. And then we will chat about the results, what we should have seen, and then we'll talk about the renal clearance as well, all right? So we'll come back in a few minutes, we'll do this one, we'll be done.